Have you ever gazed up at a giant airplane soaring through the sky and wondered, how does that heavy thing stay up there? It seems almost magical, doesn't it? But trust me, there's no magic involved, just good old-fashioned science. Today, we're going to take a thrilling journey into the world of aviation and uncover the amazing science behind how airplanes conquer gravity and take flight. Get ready for some serious wow moments as we explore the incredible forces that make air travel possible. Fasten your seatbelts and let's get started. To understand how airplanes fly, we need to meet the four fantastic forces that govern flight: lift, weight, thrust, and drag. These forces work together in perfect harmony to keep an airplane soaring gracefully through the air. First up, we have lift, the superhero force that counteracts gravity and lifts the airplane off the ground. Next is weight, the force pulling the airplane back down towards the earth due to gravity. Then there's thrust, the powerful force pushing the airplane forward through the air. Finally, we have drag, the force that resists the airplane's movement through the air, a bit like air resistance. Now, let's unravel the secret behind the most crucial force in flight: lift. How does an airplane generate enough lift to overcome its weight and soar into the sky? The answer lies in the shape of its wings and a cool scientific principle called Bernoulli's principle. Airplane wings have a special curved shape called an airfoil. This unique shape is flatter on the bottom and curved on the top. When air flows over the curved upper surface of the wing, it has to travel a longer distance than the air flowing under the wing. According to Bernoulli's principle, faster-moving air creates lower air pressure. So the faster-moving air above the wing creates an area of low pressure, while the slower-moving air below creates an area of high pressure. This difference in air pressure generates lift, pushing the wing upwards and lifting the airplane into the air, allowing it to fly. We know how lift gets an airplane off the ground, but what keeps it moving forward? What ensures that it continues to soar through the skies? That's where thrust comes in. Thrust is essential for maintaining forward motion. Thrust is the force that propels the airplane forward, generated by the powerful engines. Without thrust, the airplane would lose speed and eventually descend. There are two main types of engines used in airplanes: jet engines and propeller engines. Each has its unique way of generating thrust. Jet engines produce thrust by sucking in air, mixing it with fuel, and igniting it to create a powerful blast of hot exhaust gases that propel the airplane forward. This process is continuous and highly efficient. Propeller engines, on the other hand, use spinning propellers to push air backward, creating thrust and moving the airplane forward. They are often used in smaller aircraft. But wait, there's another force we need to consider: drag. Drag is a crucial factor in flight dynamics. Drag is like the air's way of trying to slow the airplane down. It acts opposite to the direction of thrust. It's the force that resists the airplane's movement through the air. Pilots and engineers work to minimize drag. The smoother and more streamlined the airplane's shape, the less drag it will experience. This is why modern aircraft designs focus heavily on aerodynamics. Now that we know how an airplane takes off and flies forward, how does it steer and maneuver in the air? This is a fascinating aspect of aviation. This is where the incredible world of control surfaces comes in, playing a crucial role in flight dynamics. Imagine these control surfaces as the airplane's steering wheel and pedals, allowing the pilot to control the airplane's movement with precision and accuracy. The ailerons are located on the trailing edge of the wings and move in opposite directions to control the airplane's roll or tilting motion. This helps the airplane to bank left or right. The elevators are found on the horizontal stabilizer, the small wing-like structure at the tail, and move up and down to control the airplane's pitch, allowing it to climb or descend smoothly. Finally, the rudder is the movable part of the vertical stabilizer, the upright part of the tail, and moves side to side to control the airplane's yaw, or side-to-side movement. This is essential for coordinated turns. By skillfully manipulating these control surfaces, pilots can guide the airplane through the skies with precision and grace, ensuring a safe and efficient flight. Section 6. Back to Earth. The art of landing. Taking off and soaring through the sky is only half the adventure. Landing safely is equally important. The journey isn't complete until the aircraft is back on solid ground. But don't worry, pilots are highly skilled in the art of landing, using their extensive knowledge of flight dynamics and the airplane's control surfaces to bring the aircraft gently back to Earth. Their training ensures they can handle various conditions and scenarios. During landing, the pilot reduces the engine power to decrease thrust and begins to gradually descend towards the runway. This careful reduction in power is crucial for a smooth approach. To maintain lift at lower speeds, the pilot extends flaps on the trailing edge of the wings, increasing their surface area and curvature. This helps the airplane stay airborne while slowing down. As the airplane approaches the runway, the pilot carefully adjusts the pitch and uses the ailerons and rudder to maintain control and alignment with the runway center line. Precision is key to ensure a safe landing. Once the wheels touch down, the pilot applies brakes to slow the airplane down, eventually bringing it to a complete stop. This final phase of the landing is just as important as the approach, ensuring the safety of everyone on board. Section 7. Soaring through science. A quick review. We've covered a lot of ground today, so let's take a moment to review the key takeaways of our flight adventure. 4 forces govern flight: lift, weight, thrust, and drag. Lift is generated by the difference in air pressure above and below the wings, explained by Bernoulli's principle. Thrust propels the airplane forward, generated by jet engines or propeller engines. Control surfaces like ailerons, elevators, and rudders allow pilots to maneuver the airplane. Landing involves reducing thrust, extending flaps, and skillfully controlling the airplane's descent. Section 8. Feathered friends, birds and flight. Did you know that birds, our feathered friends, use the same basic principles of flight as airplanes? Just like airplanes, birds have wings with an airfoil shape that generates lift. They flap their wings to create thrust and use their tails for steering and stability. Birds have been mastering the art of flight for millions of years, and their incredible abilities continue to inspire engineers and scientists to this day. Section 9. Keep exploring. So the next time you see an airplane soaring through the sky, remember the amazing science that makes it all possible. From the 4 forces of flight to Bernoulli's principle and the skillful control of pilots, there's so much to learn and appreciate about the wonder of aviation. Keep asking questions, keep exploring, and never stop being curious about the world around you.